let's look at another expected value calculation. So this time, going back to D&D, there's an enemy called a bugbear, which has nothing to do with bugs or bears, but it often attacks with a morning star, which is like a club with a big spiky ball on the end, which may or may not be a real historically valid weapon, but who cares? If it hits, it deals 2d8 plus 2 damage. So you roll 2 dice with 8 sides each, and then add 2 to that total to get the total damage. So how much does that do on average is your question. And we can make a table like we made some of these in class for 2d6. But the first die roll is 1 through 8. The second die roll is 1 through 8. And then we add each of these together and then add 2 to the result to get the total damage. So the minimum would be 4, but that's pretty unlikely because you'd have to roll a 1 and a 1 on both dice. And the max would be an 18, but again, that's pretty unlikely. You can see there are a lot of numbers in the middle, like 9s, 10s, 11s, 12s that seem a little bit more common. So like we did on that handout in class, we just summarize this. So a 4, the probability of that, and here I used a formula, but the simple thing is that there's 8 by 8, so there's 64 total squares here. And again, using dice, we assume the outcomes are equally likely. But then these sums are not equally likely. So this, this just works out to 1 over 64, which gives you a little less than 2% chance. Similarly with a 5, I used the formula, but if I didn't, that worked out to there's 2 5s in 64 total outcomes. So it works out to 3.13%. So what we can do here is we can calculate the expected value, how much damage this weapon does on average. So again, we can do that using the formula way where we put in this extra column for x times p of x. And I'll go ahead and center this whole thing. And then I just do this times this, multiply those two, copy the formula down, and then I can add all those up to get my average damage of this weapon. And if I add that up, I get a total of 11. So the other way to do it would be just use this sum product formula, sum product, and then select the outcomes, select the probabilities, and that's it. You get the same number there just in one step. So whichever one you prefer, you're going to calculate mu, and you conclude that a morning star wielded by a bugbear does an average of 11 damage. And, the basis of a lot of video games is just looking at averages like this. Like an average of 11, it could be plus or minus a 2. Sometimes what makes the game interesting is the unlikely events. Sometimes a bugbear could absolutely cream you for way more than you expected or, barely hit you for much less. But when a lot of games are built, they're built around the idea of like, what are the averages going to be? And then they can do some testing to make sure that the distribution, the spread of values doesn't get too crazy and still remains in the realm of fun. In terms of like these massively multiplayer online games, they set it up to try to make things balanced, but then of course they need to make a lot of tweaks because once the real players hit it by the tens of thousands or millions, if it's a very popular game, they find a lot of things aren't quite working as expected. Certain things are overpowered or underpowered, and that creates a lot of drama and confusion and outrage sometimes in the communities. But to set it up, you just look at like averages and make sure things work out pretty well.